So guys, we have discussed the byte-oriented nature of a TCP protocol. And being byte-oriented is not a problem. It is in fact the TCP is designed this way. So very often we need that TCP peers exchange messages of known size. But given the TCP byte-oriented nature, we cannot be sure if the entire message is delivered to the recipient application or it is delivered in chunks or assembled. Alright, and I have already shown the demonstration of this problem. Now if you try to download 1 GB of a file over a TCP connection, when you write a TCP program to download a file, your TCP program will have an invocation to this receive from call. Receive from call or a family of functions which belong to this receive function. So obviously you will not going to receive the entire 1 GB of a file in just one shot. Your receive from will going to be invoked many times until the entire 1 GB of a file is downloaded from the server. So in this case, the entire 1 GB of a file is downloaded in small chunks. Alright. Contrary to this, sending smaller individual messages at a higher rate may result in concatenation of messages at the recipient TCP process. I have already shown the demo of this. So unless the recipient application is made intelligent to recognize the boundary of the message, application cannot process the message. The splitted or assembled messages are chunks for an application which expects a fixed size message. So for example, the TCP downloader or TCP uploader just works smoothly with TCP being byte oriented. The downloader or uploader kind of a software do not have to recognize the message boundaries. Alright, they just upload or download the entire file. But consider another scenario. Let's say you have an email client such as Outlook. So when you start the email client, your email client downloads several email from the email server over a TCP connection. Alright, so let's say your email client download 50 megabytes of data from the email server, and this 50 megabytes of data, let's say, contains 1000 emails. So from the TCP perspective, the TCP just pushed 50 megabytes of data to your email client. And now it is the responsibility of your email client to look into these 50 megabytes of data and identify individual emails. Alright? That is, your email client need to recognize message boundaries in the TCP data it has received. Until or unless your email client finds individual emails in this 50 megabytes of data, how can your email client will going to work? Alright. So we cannot modify the TCP protocol behavior. It has been designed and implemented this way. So we need to make sure that our application is intelligent enough such that our application would be able to recognize the boundaries in the TCP data it has received over a TCP connection. Right? So the solution lies at the application layer. The TCP will continue to work as it works, but we will going to introduce our solution at the application layer. So there are three types of solution. The first solution is fixed size solution. The second solution is variable size solution. And the third solution is pattern based solution. So in the next lecture video, I will going to explain the fixed size solution and the variable size solution. And in fact, we will going to implement these solutions in a project. Pattern based solution we will going to ignore because it is not a very efficient solution to implement, but we will going to discuss very briefly about it.